Welcome to the Models, Views, and Delegates module of Pluralsight's Qt Quick Fundamentals course. My name is Todd Gentili. In this module, we'll be exploring the data visualization tools that Qt Quick provides to give you an easy-to-maintain way of presenting structured data elements to the user. We'll be focusing on the list model and the list view. The list view has quite a few properties, but we'll be sure to cover the basics, including tying a list view to a model, displaying the data from the model with a delegate, showing a header and a footer, and highlighting the current row. We'll also take a quicker peek at the time-saving repeaters and the very powerful XML list model. Let's get started. Data in your application can come from a variety of places: a C++ backend, internal data you've typed in, web API calls, a database, and more. In your QML, you can consume and describe that data in a data model. The basic complete model types built in are the list model, the XML list model, and the visual item model. There are also a few basic views provided that are designed to work with the data models. These include the list view, grid view, and path view. Views support the concept of a delegate. A delegate is nothing more than a chunk of QML that describes how you want each row of your data to be displayed. A delegate does have some special context, though. It has access to both the view and the model, and it has access to not just the model properties, but also any signals and methods in the model. At first, having access to the view and the model doesn't seem like anything special, because if you know the IDs of the view and model, you could just use those IDs to get access. But the delegate has a way to walk up the chain, so to speak, to find the current list view and the current model. This can make your delegates much easier to reuse in multiple views. We'll look at the exact syntax and the trick that makes this work in the demo. Finally, the delegate can change the data in the model, and the view will automatically update. A list model is pretty powerful and reasonably straightforward. While it does have a number of properties and functions, the primary building block is the list element. You can add list elements statically or dynamically to a list model. In fact, most of the properties or methods perform simple operations on the list model as a container for list elements. You can append, remove, move, get, set, clear, and count the list elements in the list model. We'll take a look at the parameters in a minute. There are only 3 other properties or methods: the sync method, which synchronizes a list model; the set property method, which is similar to the set method but allows you to change a single role in the list element; and finally, the dynamic roles property, which we'll also discuss in just a moment. First, we need to peek inside the list element box and discover the roles that describe your data element and the data itself. Here's a simple list model with an ID of list model ID. The list model has statically defined list elements, and each list element has 2 roles, one for name and one for category. The role names can be anything you want, but if you're creating the data, do yourself a favor and avoid common property names like text and color. Having a name collision isn't the end of the world. There is a syntax to resolve the name to your model, but it still can lead to confusion for anyone maintaining your code. Now that you've seen a role, I can talk about the dynamic roles property. It allows the type of a role to change. That is, we can specify the first list element with a name that is a string, then we can change it in the second element to be a number. There are some limits to this, however. First, you have to set the dynamic roles property to true as the first thing you do. Second, you can't use static list elements like we did in the previous slide. You have to use the methods to dynamically add list elements to your list model. Third, dynamic roles is not performant. It's up to 6 times slower depending on your platform. That is why dynamic roles are false by default. And that just leaves the set property method. This method takes 3 parameters: the index of the list element in the list model you want to change, the name of the role whose value you want to change, and finally the new value for that role. So in the list model we showed earlier, if I want to change Anders to Todd, I would specify the index as 0, the role name as name, and finally the new value as Todd. Before I return to the parameters for the various list model methods, let me discuss the JS Object Dictionary term that you're going to see in the documentation. For the list elements we've been discussing, the JS Object Dictionary syntax would look like this. If you watched my first course on Qt, you'll probably recognize this as JSON syntax. I'm not going to go into all the details of the JSON syntax. Just remember there's a nice online JSON editor that will validate your syntax for you. Now that we know that, we can visit our list model methods. You can see that a number take the JS object dictionary as a parameter. The get method returns a JavaScript object, so you can use straightforward dot notation using the role name. We'll be doing this in the demo. That's enough about the list model. Let's take a look at how to use it. Here's about the simplest list view that I thought would be instructive that consumes our list model. You can see the model property specifies the ID of our list model. It has some explicit width and height, and it has an inline delegate to display the data. Now, an inline delegate obviously isn't going to be very reusable, but it can still be a useful technique, and it makes for a nice compact example. You'll notice the delegate is just going to create a row of data with 3 text elements. The first text element is using the dynamic index property. As our model feeds us data, it also updates the index on the list model to reflect where the data came from. The next 2 elements just put some static text to identify the roles and then extract the actual data from those roles. I put a tab character before the category static text just to give us some white space separation. This isn't very pretty, but when it runs, it looks like this. Well, that's prettier than you might have expected, but the picture of the flowers is part of my slide, not the code window. This is just how simple a model view delegate combination is to put together. Everything else is just JavaScript icing on the QML cake. A few other important properties of the list view are worth mentioning. You can create custom headers and footers for your QML area. Here's a simplified version of some QML header code. I have some very similar code for a footer area, and here's a list view that uses a header and a footer. This particular list view is just using the integer 5 for its model, and putting the index as the text for each delegate, adjusting the opacity of each element based on the index. The vertical layout direction property can be specified as ListView.bottom to top, and the header will move to the bottom, the footer to the top, and the order of your list elements will reverse. You can also set the orientation property to Qt.horizontal and get your list view to rotate 90 degrees, and the layout direction can be set to Qt right to left. Now the results shown here are a little bit of a lie. Just changing the orientation property won't turn the vertical version shown here into the horizontal version. I also had to write code to adjust the size of each list element's rectangle and modify the rotation value for the header and footer. We'll see the actual code that created these 4 samples in the demo. Speaking of demos, let's move to Qt Creator and get started on that in the next clip. Here we are in Qt Creator with a new project, and I have some of the code from the slides already entered. The list model is here with an ID of list model ID and 7 static list elements. There is also a list view with an ID of list view ID, and its model property is set to our list model ID, and it has a simple inline delegate. In this example, there are only 2 items, and I'm using a simple JavaScript statement to prepend the index number and a period to the model name in the first area, and the second is displaying the category. This probably won't look how you expect, and I think the troubleshooting steps will be instructive, so let's give this a run. You were probably expecting either all the items to show up or none of the items to show up. I was expecting none of the items, but we got 1 item. Even with just 1 item, since the list view inherits from Flickable, I would expect clicking and dragging to have some effect, but it doesn't. So what's going on? Let's go back to the editor and let me depart from our regularly scheduled programming, or as my wife would say, get distracted. And it is a tangent, but I think it's both an important and instructive one. When you're learning a new technology, things often behave in unexpected ways, so it helps to have some ideas to help troubleshoot. Let me introduce a new QML element called component. We're going to talk about component more in a minute, but all we care about right now is that component.onCompleted is an attached property provided by the QML engine, and we can use it to execute some debugging statements. I'll add one to the ListView object itself and have it display the height and width. I'm cheating a little in that I already know the issue is related to the visible properties of the list view. I never assigned a height or width to the list view, and that's why I thought nothing would be shown. We can run this, and we can see the list view height and width are both 0. That seems suspicious, but you have to be a little careful with expecting deterministic behavior from the onCompleted signal. The documentation will tell you that the order in which onCompleted signals fire is undefined. That means looking at this code, it's not okay to assume that the ListView onCompleted signal will fire after all the delegate rows are created. So let's create a second one in the category text area. I'm still interested in the visible area of the ListView itself, so I'll reach up and display the height from the ListView using the ID. And I'll just put out some static text so we have no trouble remembering where each message is coming from. Okay, let me move the window out of the way. This is getting a little more convincing, and we can see the truth about the undefined order. We get a message for the first row, then a message for the list view, and then subsequent messages for each row in the delegate. Unfortunately, they are all 0. While this isn't conclusive proof, it does make me think that the fact that one row displays is unintended behavior. It also explains why flicking doesn't work. There is no visible area for mouse movement to be detected within. So once more onto the breach, let's make sure our debugging technique works at all. I'll go ahead and set the anchors fill property on the list view, and we can run once more. This is more of the behavior we want. All the rows showed up, and we can see that the height from the row is being reported. It is interesting to note that after the first row's onCompleted message fires, the row height is 0. That's not surprising, but then the list view version fires, and even though the anchors property was explicitly set by the time onCompleted fires, it doesn't seem to have had an effect. When the next row fires, it appears that the list view height has been updated. So the name onCompleted might be a little misleading. The docs say that the signal is emitted after component startup has completed. Unfortunately, they don't really elaborate on what startup means or why it's in quotes. As you explore QML, you'll find lots of examples using onCompleted signals to trace out QML behavior. Just be careful about your assumptions. The QML object may have been completed from the framework's view, but it doesn't mean that all the properties have been resolved. Finally, I can now flick the list view area. That's enough troubleshooting. In the next clip, we'll decorate this list model and add some functionality. Let's make our list view a bit more attractive and refactor our code a little for reusability. Let me start by cleaning up. I'll remove the tracing statements. As a first refactoring step, let's move the delegate code out of the list view itself. I'll put in an ID named delegate ID instead, and I can just paste the code down below. A delegate needs to be in a component. We've talked about components before, but always in the sense of putting code in a separate .qml file and reusing it from there. The component keyword comes up again. It also allows us to do a very similar thing inline in our file. I'll just add a pair of braces, assign the ID I used above, and now paste in the code. Let me reformat. And we now have a more reusable component. Let's run to make sure nothing is broken. And it all looks good. I want to do one more refactoring. First, I'll add a property to the list view named font size to hold the pixel size I want to use with the delegate rows in this list view. Now I can use this property in my delegate. I can just reference this property directly through the ID, and everything still looks the same. This, of course, does tie the font size to this particular list view, and that might not be what we want. The better approach is to let the delegate walk up the chain to find its owning view. To do that, the topmost element inside our component must have an ID, and we have to start our resolution using that ID. In our case, that ID is row ID. Unfortunately, the context-sensitive help doesn't work here yet. You won't find list view in the list. From here on in, you have to type everything manually and correctly. The first item is list view, then a dot, then view, a dot again, and now I just need the property name. We can run, and everything still looks good. You do have to be careful to use the first element inside the component. For example, you can't use the component ID itself. In fact, I'll try it. Since we don't have type ahead, it seems fine, but when we run, you can see the result isn't what we wanted. Let me restore the row ID and make the same change for the category text element. It's quite common to need to process mouse events in a list view. It seems sensible to just directly add a mouse area, set the anchors.fill property, and write an onClicked handler to set the current index property of the list view to the current clicked index. I'll run, but expect disappointment. We get an error message for invalid component body specification. It would appear we can't add a mouse area directly to the component, but not to worry. David Wheeler's aphorism tells us that everything can be solved with another layer of indirection, so let's add an item wrapper around our row. Of course, this is now our first object inside the component, so I'm just going to be lazy and move the ID up from the row to the item so I don't have to change my other code. I'll run, and that's really unpleasant looking. So this looks like our old problem of having no visible area. I need to tell the item to be the implicit size of the row, and of course, now my laziness is coming back to get even. I need an ID for the row. I'll just call it data row ID. Now we can reference the row and use it to set the height and width of our item. And all is well. We can click, but we can't see the effect of setting the current row. Let's fix that. Back to our list view, and we can add a highlight property and give it an inline component. In this case, a simple rectangle with the same width as the parent's width and a color of light gray. Now we can run. And when we click, we can see the row highlight, and there's even some animation running. Check out the documentation for the list model and look at the entries that start with highlight to see why this is happening. And in fact, I shouldn't have even bothered with the width setting since that is being controlled by the list view. Let's move on and add a header. Give it a width and height. I want it to have a nice gradient fill, which I'll get from a property that I'll define shortly. We'll also set a border color and width from some properties, and finally add a text area in our header. Set the text to Founding Fathers, give it a nice big point size, and center it. Let me scroll up, and to save a little typing, I'll paste in the 3 properties. We can run, and there's our header. It looks a little lonely, so let's bookend it with a footer. We want it to be the same width, but maybe a little less tall, and we'll use a solid color. The ending color for our gradient should work. Run again, and I'll flick the area, and you can see the headers and footers move with the flickable area. The last thing I want to do with this list view is look at the section grouped property. We can add section dividers to our list view, and the first thing we need to do is specify the property to use for the sections. In our case, we don't have many choices, so we'll specify the category. Then the criteria property allows us to specify whether we want to see the full category string or just the first letter. You can imagine if we were showing names from an address book, we might just show the first letter. Then we have some options on where the section label appears. I'll just use the viewSection.inlineLabels enumerated value. And finally, we can specify a component for the section itself. This is mostly QML you've seen many times. The interesting item is the value for the text property is the property named section. Let's run this, and you can see our categories now show up as section headings. Note that our data isn't resorted based on sections. Since the original data has 2 entries under C, they both group together with 1 section heading. The 2 entries for Qt were separated by the Linux section, so the Qt section shows up more than once. In the next clip, we'll continue with the demo and look at the orientation capabilities of the list view. As promised, this time we have code from the slides that produced the simple list views with the numbers from 1 to 5. We're going to look into some syntax issues and a little bit about how orientation works. The list view is up here at the top, and I've added 3 properties that are going to come in very handy. One for the font size, like we saw in our previous demo, and 2 others, one for the row width and one for the row height. Then you can see that the model is set to the integer 5, and I have some explicit height and width to the list view itself, followed by 3 IDs that specify the components to use for the header, delegate, and footer. We can see the header component. It's just a colored rectangle, and it's reaching up to the list view to get the width and height. The text is also reaching up to get the font size, although this time it's using parent instead of an explicit ID, just to make sure you know it's possible to do it that way as well. If we scroll down, we can see the component for the delegate. It's doing the same thing as the header for the width, height, and font size. It's setting its opacity based on the index, and you can see the text to be displayed is just the model index, and I'm using an alternate explicit syntax to specify it. We can scroll to the bottom to see the footer, and it's almost identical to the header. So far, there's really nothing new here, but let's run to see our baseline, and that looks pretty familiar. The first thing I want to do is refactor our code into separate files. You can see in the Project Explorer, I've already created some empty files. Let's start with the footer. I'll grab the code and paste it into the footer QML file, including the component tag. This fooled me the first time. Since the component tag is an inline way of creating a component, I thought the component tag would not be needed, but it turns out that's not the case, and it does make refactoring easier. Now that I have the code in a separate file, I need to return to main and change the syntax. I no longer need the footer ID, and in fact, I could remove the ID tag from the footer QML file, but for now, I'll just instantiate a footer component right here and run, and everything looks good. I'll repeat the process for the header, and for the delegate. Run again, and everything is still working. I want to do it one more time, and this time I want to move the list view itself. Now I can instantiate a demo list view in main. Let me just tidy up a bit, and that's a nice clean code file. We'll run again, still working. Let me create a row, and let's put 2 list views in here, and I'll change the layout direction of the second one to go from bottom to top. That's all it takes. I'm not sure why the vertical alignment is off, but I won't get distracted this time. Nice try, though. I'll add a column inside my row and put in 2 more list views, and then use the orientation property to rotate them. We'll run again, and there's the truth about what happens when you just change the orientation. I can use the flickable area to drag more of this into view. Luckily, it's not too much work to make these look like the versions in the slide. I just need to go over to the demo ListView QML file, and I think one of the easiest fixes is to just add a Boolean property. I'll name it isVertical. If the orientation is vertical, I want this property to be true. Now I can use this property to set the row width and row height properties. When it's vertical, I want the default values. When it's not vertical, I want the values reversed. And I want to do something similar for the width and height of the list view itself. And since I don't think I've changed anything in main, I need to jump back there and touch it so that my changes will get picked up when I build. And we're looking one step closer. I just need to rotate the text for the header and footer. I'll start with the header. I can add a rotation property and base its value on the isVertical property. When it's true, I'll leave the rotation at 0, and when it's false, I'll rotate -90 degrees. I can cut and paste that change into the footer, touch main QML, and run again. Looking pretty good. An interesting thing happened along the road to refactoring here. Let me go into the delegate QML file. While this was a component in the same file as the list view, I had to use the chaining syntax to navigate up to the list view. Now that I'm in a separate file, when I remove the ListView.view prefix, you can see that row width reformats, indicating that the QML engine seems to recognize the property. I'll remove the one for height and the one for point size. Touch main QML again and run. And everything still works. And of course, there's nothing magical about the delegate file. The same thing works in the header. And in the footer. Touch and run one last time, and the list views remain the same. That covers the use of the list model, the list view, the delegate, and decorators. Next, we'll take a quick look at the repeater object. It's time to talk about the repeater. Sorry, couldn't resist. We can look at the properties and methods to the repeater object that are not inherited. The list is not long. The repeater, like the list view, has model, delegate, and count properties, and they work in a similar manner, although model has a trick up its sleeve. There are also 2 signals, item added and item removed. Note that there are limitations to the lifetime of the item parameter passed by these signals. Let's switch over to Qt Creator and demonstrate a few features. Before I get started, I wanted to go back to our previous example and explain the footer alignment issue. Okay, I did get distracted after all. Here in the main view, we have a row with just 2 demo list views, one set for top to bottom and one with bottom to top. Let me jump over to the demo ListView QML file. The first thing I want to mention is that QML has clipping off by default for performance reasons, and another helpful troubleshooting technique is to turn it on. You can see it commented out here. I turned it on and immediately recognized the problem, and I'm sure some of you already knew this, but the default height I provided for the overall list view of 300 wasn't adequate. With clipping off, we didn't see the list view get truncated, but with clipping on, I did. So I made a few changes here. Instead of just hard-coding the single row height and full width, I created properties for them. I also changed the width from 200 to 180. Then I created a property for full height that calculates the height needed for the list view, and then I used full width and full height in the width and height properties. I also changed the model property from an integer of 5 to 3. Let's run. And I don't know about you, but that makes me feel better. Everything aligns and the flickable behaves the same. Okay, back to the repeater. Let me ditch the two list views and I'll put a repeater in there instead. I can set the model property to an integer, and then I can just put a demo list view component in there. In the repeater, the delegate is the default property, so I don't have to specify it. That's all I have to do. We can run, and there we have 4 identical demo list views. Now this is of limited usefulness, but we can add some variable behavior. Let me paste in a couple of variant properties. The first is an array that holds direction settings that alternate between top to bottom and bottom to top. The second is also an array where the first 2 entries have an orientation of vertical and the last 2 are horizontal. Now I can go to the single instance of the demo list view in the repeater and tell the vertical layout direction to use direction setting. And I just use the index property to get the value I want. Then I do a similar operation for the orientation property. Now when we run, we get 2 vertical and 2 horizontal list views, and the second list view runs bottom to top. When the orientation is horizontal, the vertical layout direction is ignored. Repeaters can work with list models directly as well. I just opened up the original list model demo so I could grab the list model. I'll paste it in, go down to the repeater and change the model to use this list model. And I'll change the delegate. And this time I'll actually use the delegate keyword just to show you it still works. And I'll just inline a text object and grab the name from the list model. Let's run this, and the repeater displays the data from our list model. We can even use simpler models. We can create a simple object list. I'll save some typing and paste it in. This is just an array of 2 objects that I've named object list. Also notice you don't have to use formally correct JSON syntax here. Normally the property name and service would be inside quotes for a JSON editor. It would still work if they were in quotes, but here I've skipped them. I'll go back to my repeater and change the model to use this object list. And I have to do one more thing. A direct reference to name won't work here. The repeater provides special support for string lists and object lists via the model data property. So we can just use that followed by the dot operator and then specify name. I can continue on and pull out the service field as well. And just for fun, woohoo, let's change the row to a column. While we're here, I might as well show you the string list too. I'll just type in a quick one. Since this is just a string object, I can simplify my delegate to reference just the model data property. And again, change the model to my string list, run, and there we have it. I think we've done enough repeater examples. Next up, we'll take a look at the considerably more exciting XML list model. Let me start with the public service announcement. Using the XML list model requires that you add an import to cutequick.xml list model 2.0. Easy enough to do, just don't forget. Remember list model? Sure you do. It holds a collection of list elements. An XML list model is very similar, only it holds a collection of read-only data in XML roles. We need to talk a little about the other properties of the XML list model, and then we'll talk about the roles. There are more properties than this for the XML list model, but these are the ones I think you need to know about. First is the source and the XML properties. These two are an either-or relationship. If you specify them both, the XML property will take precedence. The XML property can hold some static XML. The source property is the more useful one. It can hold a URL that points to either a file with XML or to a web API. Really, any valid URL is okay here. Going hand in hand with the source or XML property is the query property. This is how you specify what part of the XML file you're interested in. You do this with a string that adheres to the XPath syntax. More on that in a minute. The roles property, which by the way is the default property even though it's not marked as such in the documentation, holds the list of XML roles that you want to use when displaying data. Last but certainly not least is the status property. The XPath syntax can seem pretty persnickety while you're getting used to it, so it can be a really good idea to keep an eye on the status property to help troubleshoot. If you have the source in your QML resource folder, start with QRC : followed by 3 slashes and the path to your file. Here's an example of a web API from omdbapi.com. They, by the way, have one of the simpler APIs on the web that I found. Just go to omdbapi.com directly to get a single-page explanation of how to use the API. The R flag specifies the response data type. I want XML. The other option is JSON, and JSON is the default. The S flag specifies the title of the movie I want to search for. That's all you need. You can always take a URL like this and paste it into the address bar of your browser and make sure you get a valid XML document back. We'll see a response in a few slides. Also keep in mind that many of the parameters in this API only have an effect when using the T parameter, which limits your results to a single movie. I think it will help to look at a complete XML list model example so you have kind of a roadmap for the discussion that will follow. Here it is. You can see the source is set to a file in the resource area. There is an XPath query on the XML list model itself that will return a list of clips. And this example has 2 XML roles, one that pulls out an attribute of title and one that pulls out an attribute named href, also with an XPath query. So there are 2 query locations, one at XML list model and one for each XML role that you want. Now let's talk about the XPath syntax and how you construct a valid query for each location. Once you have some XML data to work with, you have to do an XPath query on that data. In QML, your query has to start with either the slash or double slash. A single slash denotes you're starting at the root of the document, and then you'll provide a slash delimited list of the XML elements that leads to your destination. Don't worry, I'll be doing some samples in a minute. Starting with a double slash means you want to find the element that you're going to specify next anywhere in the XML document. Queries find either elements or attributes. When you want to find an attribute, the ampersand is used. The square brackets specify a predicate, and there are 2 basic flavors, positional and Boolean. If the query would return multiple elements, you can use the positional flavor to specify the single specific element you want. And just to confuse us poor C++ programmers, the first element does not start at 0, it starts at 1. You can also use the square brackets and some logical operators to specify elements that also have specific attributes. This is the Boolean flavor. Time for some examples, and let's start with some XML data. Here's some XML data that resides in a text file. It actually describes the previous module of this course. The root element is named module. Then we have elements for author and title and description. Then there is an element named clips, and inside that element are a series of elements named clip. That's singular, clip. So if we want our query to return all the clips, here's a couple of ways to do it. We could use double slashes and just say we want clip elements no matter where they live. We want the first clip element found. We want elements found under module/clips. And finally, we want clip elements, but only if they have a title attribute. Let's move on to our web example. Here I use an S parameter of Breaker Morant, and we got back a root element containing multiple movie elements. We can get all the movie elements using the double slash format. Since they are all under root/movie, this will return the same results. We can ask for any movie element in the document, but specify that it has to have a title. Or we can specify it has to have a title and a year, in case we want to rule out the timeless classics. We can specify that it can have either a title or a year. In addition to using the XPath syntax in our XML list model query property, we also use it when we define our XML role elements. In our XML role, our queries have to be relative. That is, they can't start with a slash. They are going to start at the element returned by our XML list models query. Like a list element, we can set a name property to pretty much anything we like. It doesn't have to match the XML attribute or element that we're looking for, but generally it does just because it makes it easier to remember. In the first example, the name is year, and the query is looking for an attribute named year, spelled with a capital Y, like it is in our web API results. The data is a string, so we specify that as part of the query as well. The next example looks for the title attribute, again from the web API. The third example is for our XML file. Each clip has a title attribute, but it's spelled with a lowercase t. And finally, our XML file also has a title element, not an attribute. If we changed our XML model list query to return the module, we would search for this element, but without the ampersand. If you wanted to treat the year as a number, you would use the number function instead of string. If you want to process booleans, well, good luck. I would suggest getting the value as a string and then compare it to true or false or 1 or 0, depending on what your XML contains. If you had a Boolean attribute named bold, the XML role that should work would look like this. Unfortunately, it doesn't work. If the attribute exists and has any value at all, it will be seen as true. If it's missing, it will return as false. In the next clip, we'll see the XML list model in action. I already have a QML project set up to display some data from the XML file on disk. The name of that file is sample.xml. And let's peek inside. I've modified the file slightly from what we saw in the slides. I added a modules tag and then put 2 module tags inside, just so we can see a couple of items show up instead of just one. Let's go back out to the QML file, and here's the XML list model that will work with that file. You can see the source has set the QRC resource. It's using the explicit query syntax and just working down from modules to module to get the data. Then we have 3 XML roles, one to extract the author, one for the title, and one for the description. I then have a standard onStatus changed handler to help me troubleshoot by putting out some messages to the console. A little lower on the page, I have a column because I'm going to be adding more to this example. For now, I just have the one list view in my column, and its model property is using the XML list model we just looked at. It has an inline delegate that will display the title in a large font, the author in bold, and the description with no changes. Let's run. And there are the 2 entries from the XML file. I'll paste in a second XML list model that extracts the clips from the XML file. The source is the same, but this time I'm asking for clip elements found anywhere in the file that have a title and bold attribute. The title is treated as a string and the bold field is treated as a Boolean. Let me overlay the XML data so you can see that only the first 4 clips have a bold attribute. Also note that the first one is set to true, the second one is false, the third one is set to the string junk, and the fourth is set to 0. Now let me add a second list view that uses this clips ID model. The delegate just shows the title of the clip and tries to use the bold attribute such that if it's true, the text will be shown in bold. Let's run. We get 4 clip attributes as expected, but they are all shown in bold. I'll change the query so that we get all clips with title or bold attributes, which will be the same result as just getting all the clips since they all have a title attribute. We can run again, and there's our list of clips with only the clips that have a bold attribute showing up in bold. If there's no attribute at all, they don't show up in bold. One last list model. This time I'll paste in the one that hits a web API. It has an ID of OMDB ID. The source is all set up to bring us back any movie with Breaker Morant in the title. The query will give us any movie element that has both a title and year attribute. There are 2 XML roles. The first treats the title as a string, and the second treats the year as a number. Let me scroll down. And we're getting a little short on vertical space, so I'll shorten up the height of the clips list view and paste in our last list view. Let me hide the sidebar so we can see more of the text property. The text property will hold just the title if the year is before 1981. Otherwise, it will append the parenthetical phrase, "not the original," to the title. We can run, and the web service responds instantly with the requested data, and 4 entries show up, 2 with years prior to 1981 and 2 after. In the next clip, we'll look at an XML list model for the Flickr photo sharing site, but we're also going to look at some new QML objects. I have a new demo application for Flickr already written. I want to point out a couple of preliminary steps. First, make sure that you're using the latest Qt Quick Controls version 1.2. Also, you can see I have the XML list model imported, and I have an import for Qt Quick layouts. Finally, we're looking at an overview of the entire application using code folding. This view allows us to easily see that the entire application is about 150 lines long. It uses 5 properties up at the top, and we'll be exploring these 5 properties as we examine the code down below. After the properties, there is an XML list model with an ID of Flickr model ID. It has a text field with an ID of user value ID. Then we see a new QML object called SplitView. For now, just know that it contains a list view that will use our XML list model. Below that is the component delegate used by that list view. And then at the bottom is another new QML object called status bar that contains a row layout. Before we dig into our QML, let's go to the web so we can see how to construct a Flickr API call. You can start with a search for Flickr API. And top hit is what we're after. We're on the page for the API documentation, but we don't really need this level of detail. We just need to know what feeds are available, so we can just use the feeds link at the top. Under the available feeds, the top choice of public photos and video looks promising. The basic URL we're going to need for our XML list model source property is here under URL. If we scroll down a little, we can see the parameters are available. We're going to use the tags parameter to filter our results, and we need to specify a format. Let's go back to our starting page and scroll down. The RSS 2.0 feed is what we're interested in. Back to our QML, and I'll unfold the XML list model. Let me hide the sidebar so we have more of the model visible. I can scroll down and over. Now you can see the entire static portion of the source property. Let's grab that static string and jump back to our web browser. We'll paste it into the address bar and manually add the word windsurfing. There's our XML data. The first thing I want to point out is the XML namespace tag for media up here at the top. Then we have the top element channel. Then an image tab, which is actually not what we're interested in. Then you see an item tag, and that is what we're after. Directly under that, I can see a title tag. If I scroll down, I can see the end of this item and the start of the next item. Inside the first item, there are some more elements of interest, and they use the media namespace. The first is named media thumbnail. There's also a media content element, and it also has a JPEG. That's really all the information we need. You can see a property of the XML model list I haven't talked about yet on the top, namespace declarations. And you can see the syntax for declaring a new namespace, and I'm just setting up the media to be the value that was in our XML result. In the query, I'm not going to bother going down through the channel. I'll just ask for all the item tags that have the 3 elements I'm interested in, a title, and then the thumbnail and content elements qualified with the media namespace. Below that, I've just set up 3 XML roles. The first one should be very familiar. I'm just asking that the title element be treated as a string. The second role has a query to extract as a string the URL attribute of the thumbnail element, and the third role does the same thing for the content element. Then below that, I have an onStatusChanged handler that updates the property Flickr status with some information from the query process. If it works, it will be set to the count of items found. Otherwise, it will be set to a static string with an indication of what went wrong. Let me fold the XML list model. We're done with it. Let's open up the text field. There's nothing new here. We just have an area at the top of the page that we're going to use for setting the tag property that gets used by our XML list model. I'll fold that back up and let's examine the SplitView QML object. You can think of a split view much like a row layout or a column layout. It can arrange its children either horizontally or vertically. Here you can see I have the orientation set to horizontal. It has to have some area, so I'm using anchors fill to have it take up our entire window, but I'm setting the top margin such that it shows up below our text field. You can see we are going to have just 2 items in our split view. A list view holding the results of our API query will be on the left, and an image area will be on the right. Let's open up the list view. There's really nothing new here we haven't covered in previous modules either. You can see I've set a minimum and maximum width for it. It's set to use our Flickr model ID, and it's using the delegate that's specified in the component below. Well, there is one new thing. I'm setting the highlight color to lemon chiffon. The image is pretty standard. It's getting its source from the property full image URL, which is one of the 5 properties at the top, and I have the fill mode set to preserve the aspect ratio of the image. The one new thing to note here is the attached property for layout fill width is set to true. In a split view, only one child can set the fill width to true. The splitter will give us a control we can drag left and right, and the image will either fill or contract to use the space that's made available. Since we're going to be loading an image over the web, I also have an onStatusChanged handler for an image. Depending on the server load and your connection speed, this may provide a lot of feedback or the data may just fly by. That's it for the status. And for the split view itself, I can fold it back up. Let me open up the component delegate. It has a parent item that contains a row and mouse area. The row contains an image and 2 text areas. We can open up all 3 of those. The image has the source set to the thumbnail property of XML list model, and the next text area holds the title of the image. Finally, the third text area shows the URL of the thumbnail. The mouse area takes up the entire item area, which is the size of the row. It performs 2 functions. It sets the current index to the row clicked on, and it also sets the full image URL property to the full image property that it extracts from the XML list model. That only leaves the status bar. The status bar is another new QML object, and as you might have guessed, it just adds a status bar to the bottom of our window. I've added a row layout to the status bar, and while I don't think it's the most elegant of UI designs, I put another split view down in the status bar. The 2 text areas display the Flickr status and progress message properties. Finally, I've added a progress bar QML object. Its visibility is bound to the progress bar visible property, and the value property is bound to the full image's progress, which gets updated as the image loads. Let's run the app. The first item was automatically selected, so the image area on the right loaded with the full image. You can click anywhere in a row, and the image for that row will load. The progress bar flashes and the image displays. Let's do it again, and I'll slow down the playback by an order of magnitude so you can see the progress bar actually does a few updates. If you're not a fan of windsurfing, we can enter a new value in the tag text edit area. We can adjust the splitter in our footer to see more information on either message. We can resize the window, and our splitter at the top grows the image. And that's how easy Qt Quick makes it to consume web data and create an app to display that data, even if it does have a few rough edges. That completes our exploration of models, views, and delegates in Qt Quick. We started with a look at the list model and its contained list of list elements. We covered the use of the list view, including how to link a list view up to a list model and how to use the delegate and decorators. The decorators included the header, footer, and section areas. We did multiple examples showing how the data, model, view, and delegate all interact. We also looked at how you can interact with a model's items using a combination of the index property and the provided getters and setters. Along the way, we introduced the component element and the onCompleted attached property of the component element. We saw the convenience of using the repeater object, and we finished up with an in-depth look at not just the XML list model and XML roles, but possibly the world's shortest and most incomplete course on XPath. If you need to use XPath, there are many Pluralsight courses that can help. You can get a fast and more accurate overview from Module 3 of Dmitry Novachev's course. And as part of our final Flickr demo, we also introduced both the split view and status bar QML objects. Next up, we're going to look at QML support for standard dialogues. We're also going to cover some important odds and ends of QML that didn't find a home anywhere else. Welcome to the Dialogues and More module of Pluralsight's Qt Quick Fundamentals course. My name is Todd Gentile. In this module, we'll be exploring the support Qt Quick provides for dialogues. Out of the box, you can get the standard system dialog for choosing a file or folder, choosing a color, choosing a font, a basic dialog that you can use with your own customized components, and a dialog for displaying information or a question to the user and getting back a response. Along the way, we're going to stumble across some more QML components like the menu bar and toolbar and how you use actions in QML to tie those two together. We'll also take a look at the coding conventions the QML team recommends you use. There are 5 basic QML dialog objects. The color, font, file, and message dialogs share a number of common properties, and the basic dialog also shares some of these. They all share 4 common properties. The modality property allows you to set the dialog as being window modal, application modal, or non-modal. Please think carefully about using the non-modal setting. There seem to be a lot of programmers out there that create non-modal dialogs that should actually be modal. A window modal dialog will block input to its parent window and all family members up the chain or off to the sides. This is the default setting. You can also set a dialog to block input to all other windows in your application with the application modal setting. All dialogs have a title property, and while you can customize it for each dialog, there should be some root information in the title for every dialog. The root information should identify your application as the owner of the window. Different dialogs will set a property upon returning or even update a property while the dialog is open. For instance, the standard file dialog will update the file URL, file URLs if multiple items can be selected, or the folder property of the file dialog. The color dialog will update the color property when it returns and the current color property as the dialog is being used. The font dialog does the same thing with the font and current font properties. All dialogs can be visible or invisible. You declare your dialog using familiar QML syntax, so luckily the visible property is false by default. You'll often see code that never directly manipulates the visible property. That is, it never gets set to true or false. That's because the open method automatically sets the visible property to true, and the close method automatically sets it to false. All of the dialogs also emit the accepted and rejected signals, and therefore have the handlers on accepted and on rejected available for running code when the dialog is dismissed. Depending on the buttons being displayed on the dialog, there are a number of other signals and handlers available. Sometimes many buttons trigger the same signal. And since I'm going to want a convenient way to launch the sample dialogs, our first stop will be to take a look at the menu bar, toolbar, and action QML elements. Menu bars contain menus, which contain menu items, which can and most often should specify an action object. Toolbars can contain many things, but often contain tool buttons, and those buttons can also specify an action object. Let's switch over to Qt Creator and get started. Before I start on the file dialog, let me correct my spelling so that our app name shows up in the title bar correctly. Now let me move to the bottom and I'll add a file dialog object. And the fact that it hasn't changed colors serves to remind me that I need a new import. The dialogs are available under qtquick.dialogs 1.1. Now we can see file dialog is recognized. Let me add an ID. Oops, Qt Creator automatically closed off my object. Let me clean that up. Okay. We'll call this folder dialog ID, and for this demo, I'll set it to select a folder rather than a file by setting the property select folder to true. We can set the title to the app name property, and even though it's the default, we can explicitly set the modality to Qt.WindowModal. Finally, we just need a pair of signal handlers. The first for when the user accepts the dialog. We'll set a soon-to-be-created file to open URL property to the file URL that is selected. And when the user cancels the dialog, we'll set the same property to a static string. Now we just need to create the property and initialize it to an empty string. And we need a way to see the results, and I'll be super efficient, and just add the set property to our window title. Now we need a way to open the file dialog. Again, I'll start with the action. Give it an ID, set the text, give it an icon source, and finally set the onTriggered handler to just reference our dialog ID and call the open method. Now I can add a tool button to trigger this action. We can run, and there's our new tool button and icon. If we hover, the text will show up as well. Let me center the window a little better. Click the button, and there's our standard file dialog set up to select a folder. When I select a folder, you can see the results show up in the window title. If I go back and cancel out, we get the expected static text instead. Let's take a look at the file selecting version. We'll just set the select folder property to false. And there is a name filters property that allows us to filter which types of files are available for selecting. It's a bit of typing, so I'll just paste it in. This version will allow us to select any files ending in either .txt or .xml. I'll just change my static text to match what we're doing. We can run. Now our dialog is prompting us for text or XML files. We don't have any in this directory. Let me move to my user directory. And we have a couple. I'll just select the path.txt file, and it shows up in our title. While we're here, let me go back and just demonstrate that the dialog is modal. When I try to click on the main app window, the dialog flashes and stays on top. I can click on other windows. I'll click on QCreator, and that works. When I bring the application back to the front, the dialog is again frontmost. All right, next up, we'll take a look at the font and color dialogs. This time I've already added all the code we need. The actual dialog code isn't that much different from the file dialog, but I've added a new QML object for displaying the results. Up here at the top, we have 3 new properties that are just constants for indexing into an array I'll show you in a minute. And I have a 4th new property that holds the default message when nothing has been selected. We also have a short JavaScript function named setModelValue that takes an index into a list model and a value. The body of the function is using model ID, which is the ID of a list model we'll also see in a minute, and it uses the setProperty method to change the value property of the passed row to the value parameter. Let me scroll down. I'll fold these 2 actions that we've already looked at. You can see the toolbar has 2 more tool buttons, one using the color open action ID and one using the font open action ID. We'll look at the actions in a minute. I can close the file dialog too. We'll start at the bottom of the file and work our way up. It has nothing to do with dialogs, but since I want a better way to display the results of our actions, I thought I'd introduce the table view. It works in a similar manner to a list view. You just get more built-in Chrome like titles, scroll bars, and resizable headers. You specify the contents of the table view using table view columns, one for each column you want in the table. Let me hide the sidebar so we can see the full definition of the table view columns. You can see there are 3 properties being set for the table view columns. The role specifies where the data for that column will come from. The title will display at the top of the column, and the width is the initial width of the column. The first column uses the role of name, and the second column has a role named value. The model property of the table view is set to model ID. That's the list model directly above our table. Let's open it up. And you can see it contains 3 rows of data, and very conveniently, each row has a name and value property. We're just going to use these 3 rows to show the results when we use each of our dialogs. There's nothing new here from what we covered in the previous module on models. Let's go back to dialogs and start with the font dialog. It has an ID, and it's using our app name in the title property. The font dialog allows you to filter the fonts that are shown with the 4 properties shown here. Well, it's supposed to let you filter them. We'll see it in action in a minute. I have them all set to false except for non-scalable fonts is set to true. The onAccepted and onRejected handlers both call the same JavaScript function that we just looked at, setModelValue. In both handlers, the first parameter is the index into our list model and is one of the 3 index properties defined at the top of our file that we saw. Font index was set to 2, and you can see that the list element in our list model at index position 2 has the name of font. The second parameter varies. When the dialog is accepted, the second parameter is the font.family that was selected in the dialog. When the dialog is rejected, we just pass the no selection property message. So in either case, the method is just going to modify the list element for font to have the desired value. Let's run. I'll click the Fonts button. The first thing I want you to notice is how many non-scalable fonts I have on my system. Okay, it's not actually true. The dialog isn't filtering the way I think it should. Let me cancel out. When I run the second time, I now get a very short list of fonts that I can believe are the non-scalable ones. Now I'll select Courier and click OK, and you can see the result shows up in our table view. The color dialog is very similar. It just has an ID, title, and the standard handlers. They too are calling the same JavaScript method. The only difference is the parameters. They're using the color index, which is set to 1, and either passing in the color as a string or the no selection message. Let's run again. Click the color icon, select a color, and click OK. and the hex string of the picked color shows up in our table. We'll use the File dialog again just to make sure it works with our table view. And back in Qt Creator, you can see that it too was modified to use the same method. Finally, we haven't actually looked at the actions, but at this point you should be able to accurately predict what they look like. Just like the File action, they both set the text and icon source properties, and then the onTriggered handler calls open on the corresponding dialog. Next, we'll finish up with dialogs by looking at displaying messages or questions to the user and see how a custom dialog is created. I've added the basic scaffolding that we need, but I want to point out that 1.1 is not the latest version of the dialogs, and it doesn't have support for the custom dialog, so let me update that to 1.2. With any luck, by the time you're watching this, the latest release will fix the template and code completion. You can see I've added two more index properties for message index and custom index. And to go along with that, I have two more actions. The one for the message dialog is calling open on message dialog ID, and the custom dialog is using custom dialog ID.open. I also have added two tool buttons for these two dialogs. And finally, down below, I have a couple of empty dialogs with the IDs set. Let's start with the message dialog. I'll set the title, and the message dialog has a text property it will display to the user, so we can just type in our custom message. And since we're asking a question, we can set the icon property to display the question icon. There are only a handful of icons to use, and they are documented under the help topic for the message dialog. You can see we get an OK button by default, which for this question is fine since the question is obviously rhetorical. But if you need more than one button, you can use the standard buttons property. Again, the help documentation has a list of the available enumerations. You can see there are quite a few standard buttons to choose from. You specify more than one by using the logical OR operator to separate the buttons you want. I'll add yes and no, even though we have no need for the no response. That works, but we need to do something with the response, and this might surprise you. I'll add an onAccepted handler and set the message to yes when we get that, and on the onRejected handler, I'll set it to no. I'll run, select no. I can't bring myself to do it. I'll click yes. But the answer doesn't show up. Why not? Well, when you're reading the documentation, note that yes is defined with the yes role, not the accept role. And no is defined with the no role, not the reject role. So we have to use the handlers for those roles. That's better. Let's move on to a custom dialog, and let me pop in a calendar object. The calendar is part of Qt Quick Controls 1.2, so if you're importing 1.1, be sure to change that. I'll give the dialog an explicit width and height, give the calendar itself an ID, and have it get its width from the parent. When the user double-clicks a date, I want to dismiss the dialog. So I'll call click on the dialog and fake a standard button OK key press. Be careful not to use a fully capitalized OK. The enumeration has a lowercase k. Now I can add an onAccepted handler to the dialog, and we'll set the model value with the calendar's date, and we'll format it using the toLocale date string function. There are a couple of other features of dialogs we can look at. We can also write a handler for on button clicked. I'll just put a message out to the console, and the dialog has a clicked button property that I can use to see which button was clicked. I'll just write out its value. I'll double click a date, and in the console you can see that the button clicked signal fired, and we got the value of 1024. I've replaced the calendar custom object with some more pedestrian QML, but there are a couple of new things here too. You can see I start by setting a height and width. Then I create my own signal with the QML signal keyword, followed by the declaration for a JavaScript function named heckYeahClicked. If I needed parameters, I could add those as well. If I scroll down a little, you can see there's a row that contains an image and text area. The text area contains two buttons, a button with the text Yeah and another with the text Heck Yeah. The Yeah button has a clicked handler that just calls the custom dialog's click function and fakes the standard button OK. I could have done something similar with the Heck Yeah button and just used another rule, but I thought it might be instructive to see how to create and use your own signal. So when it's clicked, you can see it's raising our Heck Yeah clicked signal. A little further down, you can see the handlers for the two buttons. The Yeah button is just using the standard onAccepted handler, but the Heck Yeah button is using the handler that got created for our custom signal. This is automatic, and it's just named starting with on and then the name of our signal where the first letter has been made uppercase. Let's test it out. That wraps up dialogues. We just have a few more topics to cover in QML before you can unleash your mad QML skills on the world. The Qt project team has some coding convention guidelines they recommend you follow. I haven't always followed all of these rules in my demos, but demos serve a particular purpose. My recommendation is that you should do your best to follow the team's guidelines. The rules start with how to structure your QML code. Then discuss the recommended way to use group properties. There's even a recommendation for how to create a property best kept private, some information on dealing with lists, and finally, recommendations for writing your JavaScript. In addition to the JavaScript recommendations they give, I would encourage you to write your own JavaScript to Douglas Crockford's guidelines and create JSLint clean code. If you don't know what that means or want to find out why I think it's a good idea, Pluralsight has generously made my micro course on JSLint available for free. You can find it on YouTube using this shortened URL. Back to QML and the preferred structure. Here's a code sample written to adhere to the guidelines. The first thing in your QML should be your ID. The team doesn't recommend the ID suffix I used in this course, but I'm thinking I may start using that all the time. I think it makes it easier to identify the ID from other properties. Next, you add your custom properties. Then, if you have any signals, they follow your properties and precede any JavaScript functions in your file. Then come the object properties. Child objects follow the object properties. The states follow the child objects, and then at the bottom you have transitions. So to summarize on one slide, that's ID, custom properties, signals, functions, object properties, child objects, states, and transitions. When writing group properties, prefer the grouped notation when you set multiple properties of a single group. You can use inline syntax or break them into multiple lines. Avoid specifying the group name over each time on multiple lines. There is no official private keyword for creating a private property, but you can use a Qt object and put the private properties inside the Qt object as shown here. When creating a list of one item, what to do about braces? Forget about it. Write your single statement without them. When you have a simple JavaScript expression, just inline it. When you have a few lines, block format it. When you want to reuse the same expression or when it gets a bit longer, prefer a function. Well, that pretty much does it. I haven't managed to cover everything QML has to offer. In fact, I've missed quite a few areas, but I feel I've covered everything you need to know to get out there and start creating Qt quick solutions. The online help is a great resource and you should use it. I find I leave Qt Assistant open all the time I'm coding and I live on the search pane. I do want you to be aware of the functionality I didn't cover though. If you find yourself wanting to draw custom art using lines, curves, images, text, shadows, gradients, and in general do some low-level pixel banging, then go read up on the canvas. If you find you want signals that go to multiple handlers, or want the signal to travel outside the scope of the signal creator, or even to a target not inside QML, C++ anyone? Then read up on the connection object. If you're desperate to do some SQLite from QML, take a look at the local storage object. If you need better performance or want to lazy load some QML, check out the loader component. If you want to knock out some unit tests for your QML, then import Qt test and check out the Qt quick test reference documentation page in Qt Assistant. Want to trigger an action at a regular interval or even just once sometime in the future? Check out the timer object. If you're an accomplished multitasker and wondering how you can do more than one thing at once in QML, then check out the worker script. Well, that was fast and fun. We covered the 3 basic dialogues: selecting files and folders, colors, and fonts. We looked at the message and custom dialogues and saw how we can pretty much create any dialogue we want with any buttons we want. Along the way, we met the signal keyword, the calendar component, and the table view. We ended up with a look at the coding conventions and some interesting areas of QML, from pixel banging to database access, that we didn't have time to delve into, but depending on what you need to do, you might want to check out the documentation and learn more. Congratulations, you've made it to the end. Along the way, we touched on a large portion of the Qt environment, including mastering the basic syntax of QML and how to effectively leverage JavaScript. You should be comfortable with a variety of ways to lay out and control the positioning of your UIs. The basic building blocks should be very familiar to you now, and you are also aware that there's a lot of other tools available to you in the Qt toolbox. You've gotten familiar with getting information from the user via either the mouse or keyboard, and you've seen the fun you can have and the modern niceties you can add to your application with animations. The power of the model view delegate approach was explained, and if you ever need to consume a web API in XML, you now know how to impress your boss and take a seemingly difficult task and knock out a solution during your lunch break. And we just finished up with a look at how to create various dialogues. If you're new to declarative programming, I'm sure this course was a lot to take in. Feel free to watch it again. If you're already familiar with a technology like WPF, you already have a running start on writing Qt applications. Also, please remember to rate the course and use the discussion board if you have questions on material presented in the course. Finally, I just want to say thank you for spending your time with me. I hope you found the course both fun and educational, and that you're a fraction as excited about the potential of Qt as I am. It's quickly evolving and getting better and better with each release. I hope you'll continue with me on our journey. In the next course on Qt, I'll show you how to bridge the gap between your C++ and QML code. Code in peace.